Okay, so today we're going to talk about limacons. On the bottom half of your green sheet, you should have taken some notes on that. Okay? So the first thing, when you see R equals A plus or minus B cosine theta, or R equals A plus or minus B sine theta, okay, where A and B are some sort of, we're going to see integers. Okay, they could be any number, but we're going to see integers. Then we have a limacon. Okay, they were weird shapes, weren't they? Okay, they looked circle-ish, but they weren't really circles, were they? No. All right. So first of all, just like any other function, what does the sine and cosine determine? Okay. So let's describe that as symmetry. Okay. But you also noticed that your funny shape was more to the right or more to the left or more up or more down than the rest of the picture, right? And that's what you're trying to tell me with left, right, up, down. But it also determines which axis it's symmetric about. Sine is symmetric about which axis? Vertical axis, okay? And cosine symmetric about the polar axis or the horizontal axis. Okay, the plus or minus, what does that determine? Okay, what's the second thing on your, how do you know which direction the graph extends to? What did you write there? Okay. So this plus or minus is going to determine what direction this is quote unquote opening. Okay. So if it is, if we have a positive, what does that mean about our curve? If it is about cosine, it's going to be more to the right. If it's sine, it's going to be more to the up direction. Sounds funny, but we'll go with it. Okay? If there's a negative in between there with a cosine, our curve is going to be more to the left. If it's sine, our curve is going to be more down. Okay? All right. Then you had to look at A plus B. What did you notice about A plus B? You look at a lot of these curves. What did A plus B give you?
How flat it was?
How flat it was. You're on the right track, but you're not quite there. Okay, it has something to do with its size. Okay. What is something that we look at every single graph? What's the second thing I tell you to determine on a graph in that little list that I give you on your worksheets? Okay, so when you're telling me that it affects the size, it does, because whatever A plus B is, that is giving us our max R value. Okay, that's the furthest it extends from the pole. Okay, in whatever direction we have up here. Okay. What about A divided by B? This is something that you probably had to look up in your book. What does A divided by B tell you? This is something you had to write down for the next part. If you drew the pictures, you should have looked at what A divided by B gave you. Okay. A divided by B is going to give you the type, and we're going to go through the 4 types. Okay, there are 4 types. there is a loop, a cardioid, a convex, or a dimpled, and then a convex. And we'll go through the 4 and how we determine which one is which. Okay? So let's bring this all together. Okay? If we have a plus b cosine of theta, then a majority of our graph is going to be where? Okay, this is a majority of our graph is going to be to the right. Okay? If we have a minus b cosine theta, then the majority of our graph is going to be where? To the left. A plus b sine theta, where's the majority of our graph going to be? And a minus b sine theta. Okay? Open, I mean, is a closed figure, so open is kind of a weird term, but it's easiest way to describe where most of our graph is. Okay? It's a shorter word than saying the majority of the graph is to the left. Okay, we'll just say it. All right? So let's talk about the 4 types. You look at the 4 types and you should have drawn them on your paper, correct? Okay? We're going to go in order of this A divided by B. Okay? So the first one that we're going to look at, now all of these are opening right. It doesn't matter which way they open, they're still going to look the same. Okay? So this first one is what we call a loop. Because there's a loop. Okay? We have a loop when we take A divided by B and it is less than 1. Okay? What does this second one look like? It looks like a heart, doesn't it? It's called a cardioid. Get it? Okay. This happens when A divided by B is what? Equals 1. You should have these rules written down because you looked them up in your book. Right? Okay. Notice how both the loop and the cardioid go through the pole. This one goes through the pole with the loop. This one hits the pole when it's making the heart shape. Okay. What? Is it? Thank you. Better? Okay, this one. This one looks like the Pillsbury Doughboy. Got a tummy poke, right? It looks like a circle, right? So this is called dimpled. What?
Nothing. It was just a joke.
So this is a dimpled limacron. It's almost a circle, but open just a little bit. Okay? This happens when A divided by B is obviously more than 1, but it also has to be less than 2. If it's in between 1 and 2, then it's dimpled. Okay? The last one right here, these look very similar, except this one has a little bit of a dimple. This one flattens out. It looks like a ball of Play-Doh is on the ground, kind of, and it's flattened a little bit. Okay, this is what we call a convex. And that is when A divided by B is greater than or equal to 2. If it's 2 or above, we have a convex. Okay? Now, I have a way for you to remember the order. You don't have to use it, okay? But somebody told me this one time, and it was a nice way to remember the order in which these go, okay? Because we have to be able to, we can get the coordinates just fine, but we have to know how to draw our cardioid, and these four all look very different, okay? So if you want to use this, you can. Somebody told this to me one time, so I did not come up with this. You can't make fun of me. Lou loves dimpled cuties. Lou for loop, love for cardioid, dimpled, cuties for convex. Okay? If you want to use it, you may. If you need to remember the orders. Lou loves dimpled cuties. Okay? If you want to come up with your own mnemonic device, you do that. Okay? You think this is good? I don't blame you. But it's there for you if you need it. Okay? All right, so we're going to go through a few examples. Okay? R equals 2 plus 3 cosine theta. All right, so first of all, we know this is a limacon. When you identify the shape, you have to tell me what type. So what type? Okay, A divided by B is 2/3, which is less than 1, correct? So we have a loop, or we have a loop. Okay. Our max R value will be what? Our max R value is what? Nope. Look at your green sheet. What's your max R value? A plus B. What is A plus B? 5. Okay? We will save the number of zeros for last. Okay? For this loop, the majority of our graph is going to be where? To the right. So we should have a loop where the majority of it is to the right. Okay? For any limacon that you graph, your significant values will go like this. You're going to plug in 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, you don't have to think too hard about your significant points. Okay, the roses, you kind of had to play around with a little bit. Limacons, just go with these theta values every time. You'll get your shape. So, when we plug in 0, what do we get? We get 5. Cosine of 0 is 1, so we have 2 plus 3, which is 5. Okay? When we plug in pi over 2, what do we get? 2, because cosine of pi over 2 is 0. When we plug in pi, what do we get? Careful. -1, right? Cosine of pi is -1, so we have 2 minus 3. Where do I plot -1 pi? One going backwards from pi, right there. Very good. 3 pi over 2. The cosine of 3 pi over 2 is 0, so we have 2 plus 0. And then 2 pi should always take us back to where we started. Okay? Does the loop go through the pole? Yes. If you have everything on here and you do not draw this loop through the pole, you will be docked points. Okay? So as we draw this, count with me how many times we go through the pole. It's 2, right? You had a rhythm going, it's okay. All right? Good news about limacons, I'm not going to make you find the zeros because they're not always very pretty. Okay? Like if we set that equal to 0, we're going to have to find where the cosine is negative 2/3. We're not going to do that because we're not going to have our calculator. Okay? So instead we're just going to write the number of zeros. What? Okay? Get as close as you can to the shape. Okay? I know you all are not artists, so give it your best shot, but I understand if it's not the most beautiful picture in the world, but it should at least look, I should be able to identify it as a work, okay? Questions on this one? All right. Okay, is this a limacon?
Yes.
What kind? Okay, A divided by B is 1, so we have a cardioid.
What if we put heart on
I'm going to make you write cardioid. You can remember it as a heart, but make sure you write cardioid. What is our max R value? 8. If our max R value was 0, would we have anything? No, we would have nothing. Okay. It's A minus B that we have, but A is 4 and B is 4. There's just a subtraction in between, so we have to take 4 plus 4. All right. So all we have to do is plug in 0, pi over 2, pi, 3 pi over 2, and 2 pi. So what do we get when we plug in 0? Sine of 0 is 0, I do agree, which means R is 4. Now, since this is going to be our max R value is 8, I'm going to go ahead and count by 2s. Is that okay with everyone? So I'm going to write that this is a 2. Okay? So my 4 is going to be here. Okay? When we plug in pi over 2, what do we get? What's the sign of pi over 2? 1. So what do we get? 0. Are you with me this morning? Okay. When we plug in pi, what's the sign of pi? 0. So what is our R value? 4. When we plug in 3 pi over 2, what's the sign of 3 pi over 2? Negative 1. So what's our R value? 8. And 2 pi will take us back to where we started. Okay, so we know, okay, it looks like a triangle right now, but we know this needs to make a heart shape, correct? Make sure though that it's rounded at the bottom of the heart. When we draw hearts, it's pointy. It's not pointy, it's rounded, okay? But it is pointy here at the pole. Okay, so we start here. Let's count how many times we hit the pole. So we have 1, 0. Okay. It is pointed right here, but not right here. It needs to be round. Questions? We have 2 more examples, so we can do one of each of these. Sound good? Okay, is this a limacon? What kind? Huh? Dimpled, how do we know? Okay, A over B is in between 1 and 2. Okay, what is our max R value? 7. And where is the majority of this graph going to be? It's going to be mostly to the left. Okay, because we have cosine and we have A minus B. All right, so our significant points will always look the same. Our theta values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, the easiest theta values to plug in. So if our max R value is 7, mostly to the left. I'm going to have to count by 2's again so I can fit it on this graph. Okay, you don't have to count by 2's on your paper, but you can if you want to. Okay, so here we go. When we plug in 0, cosine of 0 is, so R is 1. Okay, pi over 2, what's the cosine of pi over 2? 0, so R is 4. The cosine of pi is -1, so our R value at pi would be 3 pi over 2 would give us an R value of 4. And 2 pi takes us back to where we started. Okay. Now when you draw a dimpled limacon, first of all, are we ever going to go through the pole? No. So we are not going to have any zeros. Write none. Don't write 0, write none. Okay. Then when you draw this, okay, your dimple should be curved. The cardioid kind of comes to a point. The dimple does not. Okay, it's still kind of smooth, but just dimpled in. The biggest thing is I need to tell the difference between whether it's dimpled or convex. Okay, because dimpled and convex look very similar, except convex doesn't dip in at all. Okay. So let's go ahead and look at a convex limacon. How do we know this one is convex? Okay, A over B is 5/2, which is greater than or equal to 2, so we have a convex. Okay, our max R value is 7, and a majority of this graph is going to be where? To the right, because it's A plus B and we have cosine, so a majority this is going to open right, if you will. Okay, so same theta values here for our significant points. Okay. When we plug in 0, what do we get for R? Say louder. 7. I'm going to go ahead and count by 2 up here. When we plug in pi over 2, R is when we plug in pi, r is 3 pi over 2. And 2 pi gets us back to where we started. Okay? So remember, the convex just kind of looks like it's flattened. So we draw it kind of like it's being pushed right there. Really, limacons are not difficult to graph because our significant points are very easy. The biggest thing you need to remember is what kind it is and what that's supposed to look like. Okay? Everything else we can just plug and chug, if you will, to get these significant points, but just remembering what it looks like is the biggest thing. Now, how many zeros do we have? None. The convex and the dimples never go through the pole, so we are not going to have any zeros.